So now we're going to talk about this property here. X to the n raised to the x to the m is equal to x to the n minus m. I'm going to motivate this more than anything with some small examples to convince you of the acceptability of this rule. Okay. So let's say I have x squared divided by x cubed. Then this will equal to and actually let me also make something clear. We're actually going to be talking about essentially two rules here at the same time. Okay, this one and also this one here, x to the negative n is equal to 1 over x to the positive n. Okay, that way we can see what's happening. So if I try x squared divided by x cubed, you can see, aha, what is x squared? That would be x times x, right? Because it would be 2 copies of x being multiplied together. And what is x cubed? It's 3 copies of x being multiplied together. So it's x times x times x, okay? Now, if I were to look at this as fractions, I could see this as x over x times x over x times 1 over x being multiplied together. Because we remember that when we multiply fractions, we multiply the numerators to get the numerator of the product, and we multiply the denominators to get the denominator of the product. And here we have x times 1 would be the x times x, and the x times x on the bottom would be the x cubed. But what I also want you to remember from multiplying fractions, or from fractions in general, is that if you have a fraction with the same numerator and denominator, then that fraction equals 1. So this fraction equals 1, this fraction equals 1. So 1 times 1 is 1, and 1 times this is just 1 over x. So this expression simplifies to 1 over x, okay? And what I can see is that based on this rule, okay, well actually, before we go further, this is the same as 1 over x to the first power because of what we had seen earlier. And 1 over x to the 1, if I look at this rule, going to the left becomes x to the negative 1. Okay? Okay. Because if I take, so here this says x to the negative n is equal to 1 over x to the positive n. So if I have 1 over x to the 1 power, then that's the same as x to the negative 1 power. Now let's see if this blends, if this meshes with our property x to the n over x to the m is equal to x to the n minus m. Aha, x to the 2 over x to the 3 should be x to the 2 minus 3 if this property is right. 2 minus 3 is negative 1. And indeed we see that this is x to the negative 1, which is what we expected from this rule. Now, let's do another example to look through this together. What if I had x to the cube over x squared? By the same reasoning as before, you can see that this is nothing but x times x times x divided by x times x, right? Because of course x squared, that's 2 copies of x being multiplied together, and x cubed is 3 copies of x being multiplied together, like this, right? And then of course, as before, we could break this up into 3 fractions. X over x, x over x, and in this case x over 1, right? Because if we multiply those 3 fractions, you will get this product, which of course is nothing but the definition of this product. And as before, x over x is 1, x over x is 1, so these basically go away because 1 times this is 1, 1 times this. I mean, this, if this is 1, this is 1, that can just be replaced by 1, and 1 times this is just x over 1, which is just x to the 1 power, right? Because any fraction that has a 1 in the denominator, so let's say 3 over 1, that's just 3. So there, this all simplifies to x over 1, which can be written as x. But we saw from our previous property that x to the 1 is also equal to x, so I wrote it like this. Now, if this property were true, then we would expect x to the n over x to the m to equal x to the n minus m. What is the n? 3. What is the m? 2. 3 minus 2 is 1. Aha, we do in fact see that this rule is satisfied in this example. And so I want you guys to learn both these rules for handling exponents, and we're going to be seeing them soon. Okay? And now I just want to go a little bit, I just want to talk about, well, anyway, we're going to leave this property behind us now. And yes.